Hello and welcome to More Interesting Maths. I'm David Myers with UTC South Durham. In this series we are looking at GCSE mathematics. This is for those of you that want to revise for your summer exams, catch up on any materials that you may have missed, or if you're a parent that's wanting to help your kids out at home. Generic introduction clip over, now let's do some maths.
So today, folks, we are looking at expanding to brackets. Again, where things for me get really quite exciting. And I think the title can be just a little bit misleading. What we're going to do is expand that slightly. Forgive the cheesy pun, but I'm not sorry. We're going to look at actually expanding multiple brackets. To begin with, we're going to give you the flavour for getting used to expanding two brackets. But the technique that I'm going to show you actually shows you how to expand 3, 4, 5... as many brackets as you like. So without further ado, we already know that if we were to expand these brackets here, we would do x times 2, which is 2x, and x times y, which is xy. So we would have 2x plus xy. But what if we wanted to expand something slightly bigger? What about this x plus 2 times x plus 3, or x plus y plus 1 times x minus 1? We can treat it, again, coming back to the rectangle that we looked at in the last video on expanding brackets, by doing x plus y times a plus b. And if we wanted some generic formula, what we can do to begin with is try and figure out the area of each rectangle. Say, for instance, this here would be a times x. Over here on the right-hand side, this would be a times y. Over here, bx, and finally, by. So in that step, we've answered both of the questions that are hidden here. By using the sides of the big rectangle, I wanted my arrow there, we would be looking at x plus y, the width, times by the height. X plus y times a plus b. But if we added up all these areas, then we would have the combined area. It doesn't matter what the numbers are, that formula would tell us the area of this weird and wonderful rectangle. So to expand out two brackets, there are two ways we can do it, and what I am going to do is step away from the slides this time actually, because I like this method and it's a good one, and loads of you are familiar with the FOIL, or the claw, or whatever you want to call it. Me personally, I like to stick with the method that we've seen here. It's just the grid method, but in disguise. Because what we have here are four choices. We can multiply x and y, we can multiply x and 3, so we've done x times y, then x times 3, and then we can do 2 times y, given here, and that will give us 2y, and then we can do 2 times 3 to give us 6. Me personally, I prefer what is known as the grid method, so what I'm going to do very quickly is pull up my OneNote, and I'm going to change it here because I am leaving you a link in the description, and that will sit there for you as a reminder. I'm going to pick a few values. What I'm going to do, however, is call both of them x. So let's say we're going to expand x plus 7, and let's go with x minus 3. Why not? And all I'm going to do is draw the slight same grid. However, for you lot, I'm going to make it look like the rectangle did. So I'm very lightly going to draw in the other parts of the grid so you can think of this as just another rectangle. Because here we have a little square, x times x, that there is x squared. Here we have x times 7, 7x. X times negative 3 gives us negative 3x, and 7 times negative 3 would give us negative 21. And I'm skipping ahead from the slides here, but I will recap it. What we are looking at is x squared plus 7x from the top row, minus 3x, minus 21 from the bottom row. And we can see quite quickly that these two we can combine. 7x take away 3x. X squared stands on its own from collecting like terms. 7x take away 3x gives us positive 4x. Negative 21 sits on its own. There you have expanded two brackets. I will quick fire another example for you, if I can scroll down on this thing. There we go. Let's pick a couple of numbers. What's the time at the minute? 10:28. Oh, why not? X plus 10 and x plus 28. Why not? We're going to expand these two brackets. Same as always, we'll put x plus 10 in the top and x plus 28 down the side. X times x is x squared. X times 10 is 10x. X times 28, 28x. And thankfully the time was being really nice given that the first hour is 10, because 28 times 10 will just be 280. Which means altogether we are looking at x squared plus 10x from the top, plus 28x plus 280 from the bottom. Which means altogether we have x squared, 10x plus 28x will give us 38x, plus 280 all together. With that, I'm going to take away the links in the description, because the links in the description came from Dr. Frost, although I have included a link to Dr. Frost's website later on. But if we expand these brackets, if you try it for yourself, then you would end up using the grid method, my personal favourite, I admit, with x squared plus 3x plus 2x plus 6, which we can combine to get x squared plus 5x plus 6. This one's a little bit sneakier. You would get x squared plus 1x minus 1x minus 1, and you'll notice that these two in the middle are going to cancel each other out. Plus x minus x, they'll cancel each other out to leave us with x squared minus 1. And that's a sneaky introduction to difference of two squares, but I'm going to leave that one for now. 2x minus 1 plus times x plus 2, we would get 2x squared plus 4x, that comes from the 2x times 2, minus x minus 2. These two will simplify to give us 3x. The 2x squared and the minus 2, they stay well enough alone. 2xy, 2x times 6 is 12x, minus 2 times y is minus 2y, and minus 2 times 6 gives us the negative 12. Sneaky one in the bottom. Rewrite this. The number of students that will lose marks in the GCSEs because they'll try and skip a step or they'll try and jump ahead. Be very careful. Rewrite anything like this immediately as what you know it to be. You know that 5 times 5 is 5 squared. You know that 7 times 7 is 7 squared. X plus 3 squared is x plus 3 times x plus 3. Don't simply try and square what's in the centre. Loads of people make that mistake. Do not do it. If I had any computational skill about me, I'd have a big red warning sign flashing up at the minute saying, do not do this. It's a bad idea. Rewrite it as x plus 3 times x plus 3. Because then when you expand it, you should get x squared plus 6x plus 9. The correct answer. Similarly down here, rewrite it as x minus 2 times x minus 2 to get x squared minus 4x plus 4. Okay, massive well done, as always, if you got those right. It was questions 1 to 11 that you really wanted to be paying attention to, and don't forget your laws of indices towards the end. X squared times x squared, that's going to be x to the power of 4. X cubed times x cubed, that's going to be x to the power of 6, and so on. Shifting on, we we can think about expanding square brackets fairly quickly. If you were to, why not? I'll do it in the OneNote. The link's in the description anyway. Let's shift on to my OneNote scene, because I'm a one-man working here. We'll notice a generic solution comes up if we were to do something like x plus, let's call it a squared. Notice when we did x plus 3 times x plus 3, we got x squared plus 6x plus 9. I guarantee if you were to try something like x plus 5 times x plus 5, you would end up with x squared plus 10x plus 25. If you were to do x squared plus x plus 10 squared, you'd get x squared plus 20x plus 100. How is it that we can make that sort of mental leap so quickly? Well, let's have a look at x plus a times x plus a. We'd get our x squared, we'd get an ax, we'd get another ax, and then we'd get a squared. Well, what does that mean? To cut the long story short, we would be left with x squared plus 2ax plus a squared. What does that mean? When I mentioned x plus 5 a little moment ago, if we were to square that, then to get this number in the middle, we'd simply double this. X squared plus 5 times 2 is 10, and 5 squared is 25. If we were to go with something like x plus 7 squared, we'd still get the x squared. Double it to get the number in the middle, and square it to get the final answer. That's just a little trick, by the way. If you were to expand brackets in the usual way, that'd be absolutely fine. All we're doing here is getting a bit of a shortcut to help us out. But going back to the slides, what we now have is just the quick fire method for doing it. So x minus 5 all squared. If we square this, should include that up there just in case you wanted to pause it for your own notes. X minus 5 squared, notice both of these are going to give us an x squared term. Double minus 5 gives us minus 10x. Double minus 8, we would get minus 16x. Square of negative 5, be careful, a minus times a minus is a positive, to get positive 25. Square negative 8 to get plus 64. Same pattern all the time. We've got to be fairly careful with this next one, because this is going to become a 2x all squared, which would give us 4x squared. If we were to square 3x, we would end up with 9x squared. Now we've got to be slightly careful. It'd be very tempting to just say, well, it's 2x plus 1, and that's 2x. But remember, there's 2 of them, so we need to now double it. So we need to double, the same as we did in here, x times minus 8, that's minus 8x, double it. So in here, 2x times 1, that's 2x, double it. That gives us plus 4x. 3x times negative 2, that becomes minus 6x, double it, minus 12x. And then finally in the end we can square these terms. 1 squared is 1, and minus 2 squared is positive 4. That is a quick way of expanding these squared brackets, but don't panic if you're not getting it. Drop back to the old grid method and eventually you'll start to see the patterns occurring. What about something like dealing with negatives? 1 take away x plus 3 times x minus 4. Think about BIDMAS, you already know this. Let's do the multiplication first. And if you do the multiplication first, you end up with 1 take away x squared, take away x, take away 12. And what you have to bear in mind from the trick that we did in expanding single brackets is that these negatives are going to turn into positives, and the positives are going to turn into negatives. So this becomes 1 minus x squared plus x, so that minus x has turned into a plus x, and this minus 12 turns into a plus 12. After that, you collect in like terms as you're used to. 1 plus 12, that gives us 13. The negative x squared stays where it is, and the plus x also stays where it is. So if we were to look at expanding, say, the following. X take away x plus 4 times x minus 1. We're going to do the times first, then we'll subtract everything from the x term. I'll give you a quick chance to pause it. That was your chance. If we expand the brackets, as you're now learning and getting comfortable with, x squared plus 3x minus 4, we will then take everything away. So this positive x squared becomes a negative, this 3x becomes a negative 3x, and this minus 4 becomes a plus 4. X take away x squared minus 3x plus 4. What can we do with that? The negative x squared is going to stay on its own. The plus 4 has just been shifted to the front because positive numbers at the start tend to be quite nice. And this x take away 3x becomes the minus 2x. So we've left the thing that we actually needed to change until the end. 4 stayed as it was, we just dragged it to the front. Minus x squared, we drew that in afterwards. And then we looked at x take away 3x to get negative 2x. Question 2 is not as awful as it looks, though admittedly does look pretty awful. Remember, 2x minus 1 squared, that's 2x minus 1 times 2x minus 1. If you were to expand that, you would get x squared, take away 4x squared, take away 4x plus 1, still in your brackets. What do we do with those? Same again. Change the sign to a negative. change the negative sign to a positive, change the positive sign to a negative, having left the original x squared at the front. We now have x squared, take away 4x squared, plus 4x minus 1, and x squared, take away 4x squared, leaves us with negative 3x squared. If you want, you could write the plus 4x in the front, so you could write it as 4x minus 3x squared minus 1. It doesn't entirely matter. It's not really an issue. And C here is where we get to the super skill number 3. We can multiply as many brackets as we want. We can keep going with this if you really wanted to. You can expand to whatever height you like. See what they've done here is multiply the first string of numbers by x. So this x squared plus x minus 2 turns into x cubed plus x squared minus 2x. And then multiplying everything by 3, this becomes 3x squared plus 3x minus 6. And the terms have been collected as usual. So again, pause the video to test your understanding. Me personally, that's my less handy counter, especially since I was counting up, but I hope you figured out I was going for 5. Expanding this bracket looks awful. And it's actually quite nice though. X times x is x squared. X times y is xy, and x times 1 is 1x. Y times x is xy, y times y is y squared, and y times 1 is y. I would have done the grid method this way, but I'm being nice and just for the sake of time and allowing you to get on with the actual practice, I'm going to plough through it. When we come to collecting these like terms, what do we have? X squared, nothing else there, so the x squared just drops down. Xy and, oh, there's another xy, so there's 2 of those, which is why we've got 2xy here. X, that hasn't been taken care of, so that'll drop down over here. Y squared sits on its own and so does y. Meaning, altogether we have x squared plus 2xy plus y squared plus x plus y. Okay, to try and make life a little bit nicer for you, what I am going to do is draw a grid for the second one, just so we can see where everything comes from. We have got, I'm going to put the x squared on the side, just because this is the shorter one, and I'm going to put everything else. Okay, good, I've got plenty of reach with my pen. X squared plus x plus 1, I'm going to stick that on the side. X squared times x squared, that's x squared times x squared. There's 4 powers of x in there, so I'm going to call that x to the 4. X squared times x squared times x, that's going to be an x cubed, and x squared times by itself is just an x. 3 times x squared is 3x squared, 3 times x, 3x, and finally I forgot to put my x squared up there, and 3 times by 1 is 3. Have I done that right? Have I made any other rookie errors? No, I think I'm pretty good. Yeah, I'm happy with that. So what do we have? We have x to the power of 4. I'm just going to tick these off as I go through, because I'm now looking for the next power of x. There's my x cubed. So we've just got the 1x cubed. X squared plus 3x squared. Ticking those off. Plus 3x plus 3. For completeness. Which ones can we combine? And the reason that I wrote these in order now is because we can just slinky on through them. Here we have x to the power of 4 plus x cubed. That's got no friends to sit with it. X squared plus 3x squared. That will become 4 lots of x squared plus 3x plus 3. Which, if I jump back into my arrow, is exactly what we're left with, although small typo in there, which will get fixed up. That should be an x cubed. Even maths teachers make mistakes, trust us folks. Okay, what's going to happen now is I am going to make my mug disappear so that you can get on with these next questions. I'll leave it well enough alone. Again, I'll set a timer that reveals the first... I'm going to go with the odd ones, because I did the even ones yesterday, so I will reveal the odd ones first, or odd letters, A, C, E, and so on. A little bit of a timer, then we'll reveal the even ones. I'm going to leave this nasty question alone. I'm not going to do a video on that now because I think what Dear Dr. Frost is going for is a really beautiful thing, but I'm going to leave well enough alone with that. That's a separate video entirely because there's loads of stuff we can do with what pops up in there. Try it for yourself though, you might spot some really lovely patterns, and the hint is Pascal. If you want to Google that name out of your own curiosity, then by all means do. Otherwise, I'm going to shut up. And there's the answers for you folks. Again, as always, if you got through the whole thing and you've gone and had a look into Google and you've had a go at figuring out Pascal's triangle, absolutely awesome, incredibly well done. If you got through questions 2 and 3 and you've had a really good stab at it, awesome. If you have just done your best and learned a bit more than you did yesterday, absolutely well done. Really proud of you, wherever you are, whoever you are. It's always great that you're tuning in, and having a go is the key bit. If you've made any mistakes, just look back at them and see if you can figure out where it was. That really is the element of learning maths. If you are getting it wrong 90% of the time, but you're learning about that 90% of the time and learning how to adapt, then you are learning maths the proper way. Well done.
And that is it for this video, ladies and gentlemen. Thank you so much for watching. If you think it helped you out with your maths revision at home, then please click subscribe to get notifications on future videos. Share it with a friend if you think it will help them as well. There is a PayPal account, but please don't feel obligated to do that. 10 or 12 pence if you think that it's worth it for you at home and you liked the video and the content that I've put out. Failing that, thank you so much to Dr. Frost Maths for the slides, for UTC South Durham for inspiring these videos, and most importantly to you at home for watching. I'm David Myers. Take care.